In this video, we're going to talk about identifying the vertex of a parabola. The vertex is one of those key points on the parabola. It is the highest or lowest point or the maximum or minimum point, depending on the way that it is opening. It is also the turning point in the graph of a parabola, which we've seen tells us where the graph changes from increasing to decreasing or vice versa. We've looked at the transformations of the graphs in that introductory video, so now we're going to actually look at how can we find the vertex of a parabola. We've seen that if we have the parabola written in vertex form, that is a form p of x is equal to a times x minus h quantity squared plus k, that the vertex is actually that point hk. Right? The transformations give us an exact way to identify what the vertex is. But what if it's not in that form? If our equation is in standard form, we can actually go through the process, which we just saw in the last objective, of completing the square to get the vertex form associated with the standard form. And if we do that to this generic p of x equals ax squared plus bx plus c, what we'll find is that the x value of the vertex is actually this expression, the opposite of b divided by 2a. And you might remember that negative b over 2a. Do you remember the quadratic formula? If ax squared plus bx plus c is equal to 0, then we found that the quadratic formula stated that the solutions were the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. And we found those, if you recall, just from applying the completing the square steps to this ax squared plus bx plus c equals 0. Well, graphically, the vertex actually occurs halfway between the intercepts. And so if we take the midpoint of the two intercepts, we actually get this value of negative b divided by 2a. And so to find the corresponding y value of the vertex, then we just have to evaluate the function at whatever the value of negative b over 2a is. Therefore, we can write the vertex from a standard form of a quadratic function as the ordered pair negative b divided by 2a, comma, the corresponding y value, which is p of negative b divided by 2a. So let's see how we can do some examples in identifying what the vertex is. Some of these functions are going to be given in vertex form, and some are not. In the first example, I have p of x is equal to the quantity x plus 4 squared minus 3. So to identify the vertex, this is in vertex form. Remember that if we have y is equal to a times x minus h squared plus k, the vertex is hk. We can also think about what direction do we have to move in from the graph of y equals x squared to get this graph. Because of the inner plus 4, we actually have to go left 4. So the vertex is minus 4 and then negative 3. Now, because there's no outside negative, that is, the value of a is really 1, the parabola did not change directions from that basic y equals x squared, so this parabola will open up. And that is because the value of a, that is the coefficient of the squared expression, is 1. What about p of x equals x squared plus 15? This is actually in the vertex form. There's no inside change, so the x value of the vertex does not change. There is an outside change of 15, which means we're going to shift up 15 to get the vertex of 0, 15. Likewise here, the value of a is 1, so this parabola does not change direction. It opens up because a is 1. If p of x is equal to the quantity x minus 10 squared, what is the vertex? Well, this time there's an inside change of minus 10, which means we're shifting right 10 units, but there's no outside change, so the y value of the vertex stays at 0. This parabola also opens up because there is no reflection. The value of A is 1. Part D is P of x equals negative, in parentheses, x minus 3, quantity squared plus 5. So because of the shifting right 3 units and up 5, we have a vertex at 3, 5. But notice there's also a negative on the outside of that squared expression, which means there was a reflection, which will change the direction of the parabola to open downward. So this parabola opens down because A is negative 1. So if A is positive, we have a smile, and if A is negative, it's going to frown or open down. Now in these next 3 examples, our parabola or function is not given in vertex form. It is given in the standard form. We have P of x equals x squared plus 8x plus 7. You have an option. Here you can either go through the steps of completing the square to write the function like we did in objective 1, or you can just simply apply the formula. And so if we want to apply the formula, and I'll show you both ways. The formula states that x is equal to negative b over 2a. And again, what are we finding? This is the x value of the vertex. Well, in this function, a is equal to 1, b is equal to 8, and c is equal to 7. So to find the opposite of b divided by 2a, we would find the opposite of 8 divided by 2 times 1, which is negative 8 over 2, or negative 4. So the y value of the vertex is found by doing p of negative 4. So we would have in parentheses negative 4 squared plus 8 times negative 4 plus 7. And this is 16 minus 32 plus 7. Or negative 16 plus 7, which is negative 9. So the vertex is negative 4, negative 9. Now for this particular problem, I'm going to show you completing the square, but you don't have to do it on all of these problems because it would get quite tedious. But I would have to say p of x minus 7 and leave a space is equal to x squared plus 8x. And then half of 8 is 4 squared is 16, so I would add 16 to each side. P of x negative 7 plus 16 is plus 9. And then that is equal to x plus 4 quantity squared. And so lastly, I can subtract 9 to get p of x equals the quantity x plus 4 squared minus 9. So by the vertex form, the vertex is negative 4, negative 9. Part F, p of x equals 2x squared minus x plus 5. And so to find the x value of the vertex, using the vertex formula, we would take the opposite of b divided by 2a. And just notice here that a is 2, b is negative 1, and c is 5. So we get the opposite of negative 1 divided by 2 times 2, which is positive 1/4. Oh, I forgot to say, in the previous problem, because a is 1, the parabola opens up. Okay, so back to part F. So we found the x value is 1/4. To find the y value of the vertex, we have to find p of 1/4. So this would be 2 times 1/4 quantity squared minus 1/4 plus 5. Well, 1/4 squared gives us 1/16. So we have 2 times 1/16 minus 1/4 plus 5. 2 times 1/16, remember we can write that as 2 over 1 times 1/16. So the 2 goes into the 16 8 times, and the 2 goes into 2 1 time. So we really have 1/8 minus 1/4 plus 5, but the common denominator will be 8. Therefore, I'm going to write 1/4 as minus 2/8 plus 5 over 1 is the same thing as 40 divided by 8. So we really have 1/8 minus 2/8 is negative 1/8 plus 40/8 is 39 divided by 8. So the vertex is 1/4, 39/8. And because A is 2, it is positive, the graph will open up. And then part G, P of x equals negative 4x squared plus 10. Here, if we find the x value of the vertex is negative b divided by 2a. Be careful here because the a is negative 4, but the b is actually 0, right? Because there's no x term in this function, and the c value is 10. So if we take the opposite of b divided by 2a, we get the opposite of 0, divided by 2 times negative 4, which is 0 divided by negative 8, or 0. And then p of 0 is negative 4 times 0 squared plus 10, which is just simply 0 plus 10, or 10. So the vertex is 0, 10. Because a is negative, the parabola would open down.